Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to work upon a lead code easy problem, counting bits, which in my opinion should be a lead code medium problem. Let's understand the problem statement. So basically we are given an integer n as input and we need to return an array such that it defines that for every single value from the range of 0 all the way to whatever given n is, how many times the value 1 is repeated in its binary formation. So let's try to understand this with an example. Suppose our given input is 3. So the range from 0 to n would be 0, 1, 2, 3. And if we represent these values in binary, the representation would look like 0, 0, 1, 1, 0, 1, 1. And we need to return an answer array such which is of n plus 1 size, such that it represents that for every single value from 0 to n, how many times this bit 1 is being repeated. So now for the 0th position, we don't have any ones, so we enter the value 0. For the first position, we have one bit, so we enter as 1. Same goes for the second value, so we again add 1. And for the third value, we have two ones, so in the answer, we provide as 2. And this would be our array that we would return as our answer. So let's see what are the different approaches we can take. So the first approach we can take over here is of one of the previous lead code questions that we have already solved, a number of 1 bits. And let me give you an overview of the solution we had achieved previously. So if we are given any number n is equal to 5, and if we represent it in binary, it becomes 101. And if we want to find that how many number of 1 exist in the given input, we would simply do an AND operation between the number and its one value lesser than the number of itself. So one value lesser over here would be 4, and if we represent it in binary, it becomes like this. And if we do an AND operation between these two values, the answer we get is 0, 0, 1. And this would be our first iteration. Now we would repeat the same process. So now again the number we found after doing this AND is 4, and we would do an AND operation with one value lesser than 4. So 3 would become 0, 1, 1. And if we do an AND operation between these two values, the answer we get is 0, 0, 0. And the moment we get 0 answer, we break out of the loop. And at the beginning of our loop, we would create a variable count, and only initially it would be set up to 0, and with every iteration we would increase the value of count. So during this iteration the value of count would become 1, and during this iteration the value of count would become 2, and at the end when we find that the number is actually 0, we would return whatever value of count we found as the number of ones that exist in our given input. So we found that in our given input 5, it has two number of ones. We can repeat the same formula for the given input, and let me show you how we can do it. Suppose the input we are given n is equal to 4. We need to create an array from 0 to 4, and we need to calculate that for every single value how many number of ones are present in that given input. So the answer array would be, we would need to provide that how many number of ones exist. So we can create a function called count1, and for and we can run a loop over all these values, and every single time we would pass on whatever the current value we are trying to find the count for. And whenever we run this function that uses this logic, the one that we just discussed, then we would be able to find that how many number of 1 exist for every single given element. And when we get the answer back, we can just simply fill in our array and return this as answer. This solution would work perfectly fine, and the time complexity for this solution would be n, because we will have to run a loop towards the entire towards all the given values. and we for every single value we would have to run this operation, count the number of ones, and this loop runs for the time being of number of ones that exist in any given input. So over here for number 5 there exists two ones, so we will have to run the loop twice. Suppose if we are given any n is equal to like this, then the loop will run 6 times. So we can say that this solution basically works in the time complexity of big O of n times log n, because in order to find this count, because in order to find number of ones, we would have to run multiple loop, we will have to run multiple iterations in this count one solution. So this is in itself a pretty efficient solution, but we need to see that if we can find a better approach and can we have an optimal solution. We can have optimal solution. Let me show you how we can achieve that. Now, in order to find the optimal solution, first let's try to understand that how the logic actually works if we want to find the number of ones in any given element. So the operation we are doing is basically we take n and n minus 1, and then we do a counter plus plus. We can represent it in a different manner. So first let's try to understand that suppose n is equal to 9. The actual calculation we are doing is n minus 1. We are doing an AND. So basically this means that after the AND operation we get the value as, and the value this comes up as 8, and we do an a plus 1. So keeping this in mind, and again if we do it for the value number 8, what we are actually going to do is we are going to, now our n is 8, so we will do n minus 1 as 7, and the answer is 0. So basically our n is 0 at this moment, and we again do plus 1 in our counter. So if we write this in other way, we can write it as that answer for the number 9 is actually whatever the answer we found for 9 and 8 plus 1. And if we go down one step further, the answer for actually this 9 and 8 is actually the answer for whatever the value of 8 we found plus 1. We can write this exact same formation as this. And if we try to calculate the value for this uh, a of 8, actually we can write it as a of 8 and 7 plus 1 for this particular value. And this actually becomes a of 0 plus 1. And we know that a of 0 is actually 0, plus 1 is 1, and this 1 is actually the value of a of 8. Now, if we replace this a of 8 over here, we can say that the a of 9 is actually a of 9 and 8 plus 1, and we know that the value of a of 9 and 8 is actually a of 8 plus 1, and we know that the value of a of 8 is actually this 1. So we can say 1 plus 1, and we can come to the conclusion that the number of ones present in value number 9 is actually 2, and which is what we are given over here, and which is what we know. And basically what we have done is we have taken this input for any single individual element, and we have actually computed the results, we have actually stored the results, and based on those results we are able to find the future values. And basically we are applying dynamic programming. We can simply calculate the solution for our entire array in just big O of n time. Let's take another example to make things more clear. Suppose our given input is equal to 6. So if we want to find the answer for 6 using the logic we found over here, we can consider this as answer for whatever we find for 6 and 5 plus 1, and the answer for 6 and 5 is actually this equals to 4. So we can write this as answer for whatever the value of 4 we got plus 1, because this turns out to be 4. And subsequently, if we calculate the value for 4, we can break it down further as, so we can write this as answer for 4 and 3 plus 1 for this portion and plus 1 for this one. The answer for 4 and 3 is actually n is equal to 0. So we get answer of 0 plus 1 plus 1. This would be our final answer for our answer for value number 6. So see over here that we have, when we get to value number 6, we would have already calculated all the values from 0 to 5. And we, since we have the answer for from 0 to 5, we will use those answers to quickly determine the answer for value number 6. And this logic enables us to get our solution in just single iteration, and this would be a better time complexity than our previously suggested algorithm. And in terms of space complexity, anyways, we have to create an answer array in order to return it as a part of the answer, because it is given as requirement uh, for the given input, that we are not using any additional space, and we can just use the same array to represent the answer and also use it as our dynamic programming solution. So space complexity would also be a big O of 1. And this is a really ideal approach. And let's move on towards the coding. So first of all, we will create an answer array and we would give it the size of n plus 1. And now we initialize the answer array of 0th value to 0. And now we just need to run a for loop. We'll start the loop from I is equal to 1 because we already calculated the value for 0. And we will run it while I is less than or equal to n. And we just have to write one line of solution, that if our answer of current I is actually equal to answer of I and I minus 1, and whatever the result of this is, we just add 1 to it. And yeah, basically after the loop we should have our answer array completely filled up and we can simply return it. So let's try to run our code. Oh, we forgot to initialize the value. Yeah, looks like our solution is working. Let's submit this. Our submission works pretty fast compared to a lot of other submissions, and as we can see that this is just a couple of lines of code that is really doing the trick. So though this is really simple to see, but in order to come up to this answer requires very strong knowledge of dynamic programming. Hope you like the explanation and the videos. Let me know if you want me to do anything else with the videos, or provide me any suggestions on how can I improve.